When selecting a display module, many engineers face an important question. Should we choose frame bonding or optical bonding? Although both methods can integrate a cover glass, touch panel, and display module, their structures and performance are very different. First, let us understand traditional frame bonding, also known as air bonding. In a frame bonding structure, the cover glass and display module are fixed only around the edges using adhesive. The center area between the layers remains an air gap. This manufacturing method is simple, cost-effective, and widely used in many standard display applications. The main advantages of frame bonding are lower cost, easier production, and simpler maintenance. For indoor applications with normal lighting conditions, frame bonding can provide a practical and economical solution. However, the air gap also creates several limitations. When external light enters the display, it can reflect between the cover glass and the LCD surface. The SE reflections reduce contrast and make the display harder to read, especially under strong lighting or outdoor environments. This is where optical bonding provides a major improvement. Optical bonding, also called full lamination, uses optical adhesive to completely fill the air gap between display layers. The cover glass, touch panel, and LCD module are bonded together as one integrated structure. By removing the air gap, optical bonding reduces internal reflections, improves contrast, and enhances sunlight readability. Besides better visibility, optical bonding also improves durability. The bonded structure provides better resistance against vibration, shock, and environmental stress. This makes it ideal for demanding applications such as industrial displays, medical equipment, automotive displays, and outdoor devices. Optical bonding also improves touch performance. Because there is no air layer between the touch panel and display, touch signals can be transmitted more directly, providing better response and accuracy. So why does optical bonding cost more? The reason is not only the material cost. Optical bonding requires advanced manufacturing processes, including precise alignment, clean room control, adhesive management, and curing technology. Any dust particles, bubbles, or bonding defects can affect the final display quality. Optical bonding requires higher equipment investment, stricter quality control, and more manufacturing experience. In summary, frame bonding offers a cost-effective solution for standard applications. Optical bonding provides better visibility, higher reliability, and improved performance for demanding environments. The right choice depends on your application requirements, including brightness, environment, durability, and user experience. Choosing the correct bonding technology is an important step in designing a professional display solution.